Hello everyone and welcome back to the channel. In this video, I'm going to explain a post that I wrote yesterday, Sunday. In this post, I create an activity stream using Postgres. This is something that is always been interesting for me. The theories can get kind of really complicated, and you can define different type of schemas to represent this type of problems. But usually the best solution is the one that uses the shortest code or the less amount of code. So I had some free time over the weekend, so I decided, okay, let's try to create a complete activity stream system using Postgres. And let's see how can we do it in the most simple possible way. Also, one of the requirements that I set for myself is that this type of systems can produce a lot of data and a lot of information in general. So all the functionality that I needed to create for the activity stream should accomplish two characteristics. One, to directly return JSON results. And the second is to implement pagination in each of the functions that return the data. Why? Because in the first case is you need JSON results, so you don't have to take the information, read it in any programming language, then fill some classes, maybe an ORM like XPO or Entity Framework, and then serialize that again. So basically, it's a waste of time. You read the information from the database, you pass it to the programming language, and then with that information, you create class instances, and then you serialize that class instance into JSON. So it's a lot of steps that are not needed in general. So, and pagination, why? Because this will produce, activity streams in general will produce a lot of information. So you need to be able to get it by pages and define the page number and the page size. So this is the post. I'm not going to explain step by step. But you can read it. It's a little bit long, but actually really interesting. So, well, I decided to use Postgres for this example because it provides really rich JSON functionality, and it's an open source database that you can use freely in any Linux server, which I kind of like in general. So, okay, let's start. I'm going to open my favorite database administrator tool, which is DB Beaver. The more I use it, the more I love it. Free, open source. This is the community edition, but there is one paid version. And it includes a lot of functionality. The one that I like the most is that if you have geographical information in your tables, it will show it on the map. So that's super nice. Okay, so let's create a database. So this will be activity stream. Okay, now we have a database. Let's set this as default. And now I don't want to run each of the parts one by one. Here I explain why I use what each of the queries do. But there is a huge script that do everything already. This basically, the first step is that it installed the his extension, so you can manipulate geographical information. And then it creates all the tables and functions that this activity stream is going to use. I decided to create functions for one reason. I'm a code first oriented person, but that means that if you're a code first oriented person, that you will store your information in any type of structure, then you will read it in your programming language or your framework, and then you will process the information. So you have to read sometimes a lot to be able to process on the client side, or actually the server side, being the server, the application server. But I think that the most efficient way is to process it inside of the database before it actually goes to the programming language. So you save bandwidth and the processing time is faster. So what I'm going to do is I'm going to copy this script. I'm going back to dbbeaver, and I'm going to create a new SQL script. And let's paste this and run. Okay, it's done. So let's see what we have here. If we go to the schemas, we have just 3 tables. Object storage, which is a table that stores every possible object that we're going to reference on the activity stream. For example, imagine that you're posting pictures, so we'll store the information about the picture, and then you can tell something like, Hoche posted a picture in his new image gallery. So that's the idea of an activity stream. All social networks works like that. There is, well, we can see that in the article. In the first part, it says that each activity should contain an actor, which is the person who is doing the activity, the verb, which is the action that is that actor is performing. For example, Hoche is posting. Posting is the verb in that case. The object is the picture. Hoche is posting a picture. And then the target, which is where is that action happening? Hoche is posting a picture in his new album. So that's the target. And then you have some time information, when did that happen? And metadata information, which can be anything extra about the post. In this case, we didn't create any functionality for metadata, but maybe I will add it in the future to the script, because I plan to continue growing this script in time, so over time. So let's go here. So this is working. We basically created the table storage to create the objects, the follow table, which describes the follower-followee relationship, and the activities, where the activities are going to be stored. So besides that, we created some functions, but in here they will be hard to locate because, well, see, there are so many functions already built into the system. Maybe I should put a prefix for them. I will put that into the to-do list, because in here, in these hundreds of functions, it will be hard to find. Okay, so, but now let's run some examples. It's easier to understand with some examples. So we do have examples here. This is the GitHub repository where the script is, and then some test data and test scenario. So let's run the test scenario because it's the one that is really easy to understand. Okay, let's get a raw view of this. So in here it says that we need to have a clean activity stream before we start. So okay, we just created the database, so the activity stream is clean. So first we need to create some users. And I don't have the user creation here. I should update this script. So let me get that from the sample data. Let me go here. Let's go to the GitHub page again. And get the raw data from here. Okay, so here we create users and activities. At the moment, I just want to create the user. So we have 5 users. So let's create the users. And let's go back to dbbeaver. So let's run this. And see, there's been 5 users in the object storage. So if we go to the object storage here and we view it, if we go to data, see we have a table which contains the ID of the object, the latitude and longitude, then a geographical point based on this latitude and longitude, the object type, and the JSON that represents that object. And of course, the timestamps. Okay, so we have 5 users now. Okay, so let's go back to the script. I'm going to delete this so we have only one step at a time. Okay, let's go back here. So now let's go and try to find the test cases. So, okay, first we need to set followers, right? So there are 5 users, and one of them is named Alice, and this is the object ID of Alice. So we're going to make Alice follow her own activities, because if not, she will see the activities of other persons, but not her own. So let's come here and run this. Okay, so now the function was executed. Now Alice is following her own activities. So now let's get which objects is like Alice following. It will return herself because she's following herself at the moment. So let's do this. And see, it returns the ID of the followers. So those are the only followers that she has right now. She is only following herself. So let's go back here. Now let's try to get all the activities from the objects that Alice is following. At this moment, it will return basically nothing because there is nothing created already, just the users. So see, it's empty. But now is where it gets interesting. There is another user named Bob. So Bob will create an ad in the object storage table, and we will create an activity for that ad. So let's go and create the activity. And the activity will happen near St. Petersburg, Russia. So let's run this. Okay, it's done. Now, again, if I get the activities of the users that Alice is following, I will get nothing. Why? Because the activity that just happened was created by Bob, and Alice is not following Bob. So let's follow Bob so we can get his activity. So Alice will start following Bob. Let's see. Okay, so Alice start following Bob. So if we get the objects that Alice is following, it will return two, Alice herself and Bob. So here we have C1, 2. This one is, let's see, C01. This one is Alice and this one is Bob. So now Alice is following her own activities and Bob's activities. Now, if we run again this one, get all the activities of the objects that Alice is following, it will return 1. So let's run this. And here we have the result as JSON. We can get the JSON and go here and let's format this. So what happened is, this is the idea of the activity. The verb is post. So Bob posted an ad of a vintage bicycle. We don't have any place where that happens. And this is the location, the geographical location. This is the object ID, the target ID, and the actor ID, just to make sure that we have that information so we can use it in other different queries, and the timestamp when this happened. So let's see what else do we have here in the example. So this we already did because we have the queries already there. So let's make Alice stop following Bob. So if we run this, Alice stopped following Bob. She's only following herself. And if we get the activities, this will return nothing because we stopped following Bob, so we stop seeing his activities. Okay, let's continue. So let's follow Bob again. Well, let's see. We just did this. Okay, let's make Bob create more activities. So it's going to create a second ad. This is really important. So let's put more space in here. So Bob will create a second activity. In this case, he is sailing a house plan. So now there are two activities. If we get the activities of the objects followed by Alice, still nothing because we are not following Bob anymore. So let's start following Bob again. Now if we get the activities, see, now we have, it's a JSON file, so it's hard to see that there are two activities in there, but let's do that in the JSON formatter. So as you can see now, there are two JSON records. The first one is the one that, the newest one. So new activities will be always on top and all activities will go down as new activities come. So the new activity is the house plan that is on sale. And the other one was, I think, a vintage card, which is second now. So the more activities the users make, they will just fill the activities stream and it will be getting deeper and deeper into the paging system. So we're almost done with this. Which other example we have? So these are basically the same ideas. So this one is nice. Let's say that you will allow the users to see activities even from the objects that they are not following. That can happen in a social network like Instagram. For example, that you go to a specific location, let's say El Salvador, which is my home country. You go to El Salvador and you open your Instagram and you will see things that are happening around of people that you're not following. So Instagram gets your location, send it to the server, and gets some activities happening around. So for that, I created another function. So this function will return all the activities that happen within a radius of 4,000 meters by page. So we'll get page 1 with 10 records on each page. And this is the location from where I want to get the activities. So this is really neat. And let's run this. And here we have the activities that Bob did, because I know that those activities are created within the radius of the city of St. Petersburg, Russia. So that's basically it for the example. And just right now, I created 2 new functions before I start recording this video. So let's copy this just to show you what they do. So the first one will return the followers information in a table type of structure. Also, again, using pagination, because that's really important in this type of systems. So let's see. And see, you have the follower ID, and then you have the JSON information from the object storage. that represents this object. And then if we want to get just a JSON, because most of the time we will just write it to a response from an API, so we don't need to serialize it, deserialize it, and serialize it again. It's basically the same, but in JSON format. So if we go to our JSON formatter page, we can delete this. And see, these are the persons. Alice is following herself. And well, we have Alice in both cases, because I think I run that twice. So I have double relationship. But anyway, I might need to fix that. I think I did some mistakes by running the queries. So this is how the activity stream is working right now in Postgres. So as you saw, there is only like 3 tables that we're using. Special information from the keys functionality of Postgres, and a lot of the stuff we use JSON functionality also to be able to reduce the communication between the client application and the database. And as you see, everything is encapsulated in functions. That makes this database almost like an API, because you don't need to process these things on the programming language side. So that's everything for this video. I think I will continue improving this activity stream. And eventually, I will encapsulate this on a C# class. So you can write the objects from C#, which is actually the way that it should be done. And that's it. I will create other videos later of the new functionality that I will be adding. So thanks for watching. And if you have any doubts, just write them down in the comment section below. And I will post the link to the GitHub repository and to the article in the description of the video. So see you in the next video, guys. Bye.